Hello everyone, good morning. So in this new series of exercise, we continue our previous exercises. Now in exercise 10, we have this deployment namespace skate trade release. The release engineering team at Trade Corporation accidentally deployed broken image version to the flight search deployment in the SkyTrad release namespace. The deployment has gone through several revisions and the team needs to roll it back to the known code version. So this is something related to the image rollout upgrade. When we update deployment with the new parameters and we have a problem in the new ones and we will roll back to previous ones. So the first question is check the rollout history of the flight search deployment in the SkyTrad release namespace. So first we have to log inside the cluster instance and we will get what's in this namespace. Can he see that there is problem with this pod? The check the rollout history of the flight search namespace. Like first we will go to check the rollout history. So the command is control rollout history and deployment, and it will give us the previous history. Now we are in the last version, and we are in the last version here, the first version, and the question is to roll back to the deployment revision 2. So roll out, roll back, undo. Look, so the command is undo, and to revision revision 2. Well, first we have to check the revision 2. Just check history. So here it shows us what is in the revision 2. The image of this revision. If we can see which revision we are, normally we are in revision 1. The image that we are is 23. For example, revision 3, it was 25 in revision 4. Okay. We are here in revision for the last one. This is the invalid one, and we want to come back to this one, to the revision 2, 24. So the command is the same as is to rollout, but we have to make undo, and we go we add here to revision 2. Now deployment has been rolled out, and we can see that we are in. Look here, the revision 2 has disappeared. We have entry, so we are in the two revision. Before we made, we were 1 2 3 4. We were in revision 4. We were in the last revision that has the invalid. Can check the status. Okay. Now the status already done. Now we can, for example, get which revision we are, and can describe the deployment, get deployment. Mao wide. It will give us the image 24. We are in the second revision. This is very important in generally development operation when we made change of the deployment, and we will back to previous deployment correct. When we roll back deployment, it will create a new version number and the history grow ups. Like we see before, we were in number 4, it become the history number 5. So if I made a new rollback, it will change to number 6. The controller will keep 10 revision. So after 10 rollback operation, it will start back from 0 and will delete systematically the previous ones. Okay, we can annotate the deployment in case to have clear description of any change, and this can be seen in other labs. So generally, this is the most important key concepts that we can learn from the rollout operations. You can check also the release image. This is the image. Okay, can go to next exercise. Okay, in the next exercise we have the data analytics team at Skate Trade Corporation reports that their market analyzer pod in the Skate Trade Analytics namespace has been crashed repeatedly. So I can get all Sorry, oh, I have to look to inside the cluster instance before. So we have one pod inside our namespace and it's crashing. It says identify the root cause. Okay, investigate why the market analyzer pod is crashed uh, in the loop back off. So to get so the crash loop back off generally indicates that the pod is repeatedly crashing and Kubernetes is backing off. On restart attempts, it will restart infinitely. Common cause includes incorrect comments. Sometimes there is a command incorrect comment inside the pod, or the missing dependencies of other uh, pods, or a misconfiguration of an environment variable from config maps and config secrets. So let's go here and see. Okay, we will describe now if there is here successfully. Okay, we can see the mount setup to set the file for the volume config map. So if we can go here, there is one mounts. This mounts it's set from config volume, and this config volume here it is populated by config map type, and its name is analyzer config. So we can look at the event section that will explain the cause of this crash. Okay, now we can go deeper inside and we can go to the log. The log of this pod, it says that it's waiting for a container creating. If we add this previous command, it will explain the correct root cause. It says that the market analyzer that we already seen here in the volumes market analyzer. Okay, the container analyzer import market not found. So the container analyzer in the market analyzer is not found because the container has not been created. So i- uh, the pod it refer as we said reference to a config map named analyzer config that does not exist in the namespace. So the pod cannot start because the volume mount will file. So to fix this issue, we have to create a config map called analyzer config map. from to create config map, name it analyzer config with the correct parameters, and here it says the name is analyzer config. This is only the information that we have. So I will create config map, create config map, name. So very easy. In the namespace, very important. Okay, okay. Here the help, just do it. So there is two way to enter the parameters of the config map from existing file or from command line. Command line is this is the value. This is the command. So value from lateral value one, value two. So anyway, we have two parameters that if you can go to inside, we have to put them inside this value. So this the first one. So we have to make mode prediction, and I will explain why from where this is came. So back to our pod. So if we can inside the pod, there is this variable mod. Generally, in each pod, there is this etc config, but mod it's not uh, known variable for a container. So I will create inside this config map a variable for this pod. So create config map code, and I give it projection because I know that already there is a folder called projection in this container image. So the the content the config maps is created. Cut config maps. Config maps. It's here, analyzer config, and you can go to the pod. Market analyzer. You can describe analyzer config not found. have been analyzer config. This is analyzer. We back to our recording. So after creating the config maps, I found that always it show us this error: configuration config mod was not found. Even that I have already created my config maps here, analyzer config with this key value code projection. But and I have also described this is code. This is the mistake that I made and that don't allow my pod starting again. It is not code, should be mod. Look, I changed the code to mod. Sorry. Okay, I changed mod. Now, okay, get config. Now I can see that my pod is running. Look. Okay, this is the config maps. And wait a moment, and we can see that my pod is running here. So it's no more in a crash state. It's running because I have created first the config map, config analyzer, and I created my case. My case because this I have to look. I looked inside my my pod. I found this generally inside any Linux configuration. We have etc config. We don't have mod. So in this, when we see this in capital, this is a variable. So this variable should be created, and we have created in the config maps, and now it's inside my container, and my container is running, and because thanks to config maps configuration. Uh, that's all for this question. Now there is another question. The second question says, the last question, sorry, my says, now it says to save the initial error message from pod logs to this folder. Now the pod is running. There is no error. So to save previous error, there is a command not go keep control logs command and add the previous variable. So in this case, it will show you the previous error, not the actual error. Now there is no error. If we can go to uh, logs of this container, we will it will show us this output. This is not error. This is output from the container. So the market analyzer running with mod. This is if you can go to the pod, this is the log. So if everything is okay, this is command if else. If everything is okay, market analyzer with the mod. Okay, and cut this folder. There is no content inside, so there will be nothing. So I have this error. Now if I want to the previous error, I have to add the previous error that that state the, the problem. Now there is another problem of the volume mount, if you remember, because we have two problems: the volume mount and then the config mount. The volume mount. here, file to setup config vol, because there was no config vol with this name. So first we created this config map. Then when we created the config map, we added the keys to it that allowed my pod to run. So now I can also add this uh, error. So I will. This is not error. This is in warning, and we can get it not from the pod, but from describing the pod. When we describe the pod, we just make made what is the warning and save the output in the previous file. So we will save this to the in the file, and we can say the contents here. It will concatenate the error from the pod with the mount warning from the deployment on this file, and we will have why this pod has not been started in the beginning. Okay, let's conclude this exercise. So just small small conclusion. So always start with the describe command to check the events of container or pod. And after that, when you fix this problem, go to the keep control logs to describe and logs to see the state of the container, and look with common causes, something wrong image, bad command, missing config map, and secret. This is generally the error that don't allow the pod to start. uh, Sometimes if there is a mount issue, so like in our exercise, the error will not show any the pod will not show any error. Why? Because the mount is not up, and there will be no error. So we have to fix the mount before. In Linux, if you have a mount problem, the kernel will not start, so will not get error. So always fix the mount issue, then go to see the second error. So if you can remember in the beginning of the exercise here, the error was not very clear for us. I can go here, container creating, here describe first. It says the first error was not clear, but container analyzer in the pod is waiting to start. It didn't show any error. This is not given me that there is a problem with the mount or a variable, or it just showed that. So I cannot conclude anything. So after fixing the problem of the volume mount, and so the creating the config maps, I have seen this the real error here. This is the real error. In this case, I starting knowing what is the problem, because the container has started and the mount is up, and the container can make logs. And after I changed the created the mod this file is not clear, is it was not present. So I created the mode variable here, code, and changed to mode. And after that, this variable has been created and the pod is becoming running. So this is very important before creating container. And in the next exercise, we will speak about Helm charts and how Helm is very important for managing application packages for Kubernetes. And Helm is a package manager for Kubernetes, and that allow us to define and install and integrate complex applications that use generally with Kubernetes, and use Agro CD. Container deployment is declarative of GitOps continuous delivery. Agro CD is a subset of GitOps, and GitOps tools